I'd like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcasts. Thanks again for joining us for today's presentation, Introduction to Data Mining with SQL Server 2005. Now it is my pleasure to introduce today's presenter, John Weston, who's an IT Pro Evangelist with Microsoft. John, you now have the floor.
Thanks, Heather, and good morning or good afternoon to everyone, and welcome to the SQL Server webcast, and this is the one we're going to cover data mining. As Heather mentioned, my name is John Weston, and I'm an IT Pro Evangelist. What that means is I get to go around the United States and talk about our great products in person at live events, at user groups, at product launches. You see me a lot on webcasts like this, and I also do a lot of blogging and those kind of online activities. I also have a monthly radio show. If you go to TechNet, you can find the TechNet radio, and so I go out there and interview different user group leaders and talk about current technology on the TechNet radio. If you'd like to send me an email, my email address is jweston, so Jweston at Microsoft.com. I also maintain a couple of blogs. My technical blog is at blogs.technet.com, /jweston. On that blog, I do all kinds of great technical questions and answers. One of the things I really like to do is you can ask a question during this webcast, and if you watch the recorded version of this, you won't be able to see the questions that other people ask and the answers that we provide to those. So I always capture all the questions, strip out any names or any email addresses and that kind of stuff, and then post that up there to my blog. So give me a couple of days and I'll get it posted up there. Today I have one of my coworkers, Brian von Axelson. Great shout out to him. He's a good buddy of mine from Pennsylvania that's helping us out with the webcast today. So while the webcast is going on, just go down to that lower right-hand corner there, type in your question in the box, and click on Ask, and Brian will be behind the scenes here helping us out, answering those as quickly as he can. Now, be patient. There's only one of Brian, so he may be having to do some research and looking someone else's question, so be patient with him. If he doesn't get to it at the end of the webcast, I'll take a look and see if we have any leftover webcasts. But if you think of something later, don't hesitate to email me or Brian, and go to our blogs, and we'd be glad to help you with any SQL Server questions that you might have. So what are we going to talk about today? This is the data mining session. We're going to start off our discussion talking about the functions of what is data mining and how it can be beneficial in your business. We'll also talk about what data mining is and the process involved. An important feature that we'll discuss in data mining is the utilization within SQL Server role. Finally, you'll also see all the new features within SQL Server that can assist you with data mining. By the end of this session, hopefully, and that's my goal, is to have you better understanding of what is data mining, what is the data mining process, and the benefits of using data mining. A little bit of prerequisites and backgrounds. If you're familiar with integration services with either version of 2000 or 2005 SQL Server will be helpful. If you've had some exposure to either reporting services or analysis services would be helpful as well, and also SQL Server experience. Now again, none of these are required for this session, but they would be beneficial. This is a level 200 course, so it's kind of right in the middle there. We're going to go deep into a little bit of topics, but it should be general enough that anybody without a whole lot of background should be able to follow along with us. So what's our agenda for today? We'll begin the session you'll take a look at learning the process of data mining, and then we'll begin to define data mining at its different stages. The last agenda item we've got here discusses the utilization of data mining. Once we've mined this data, what do we do with it? So we'll take a look at some of the new features in SQL Server 2005 to help us with these data mining needs. To start off, we always got to do some background information, and this is the old Moore's Law. Moore's Law states that processor speed doubles every 18 months. Comparatively, hard disk space doubles every 9 months. Analysis of storage data improves decision-making, and it is vital in helping companies gain a competitive advantage. However, the explosive growth of data is becoming too difficult to analyze. In other words, the increasing data set size is outpacing Moore's Law. Improvements in computer processing power, disk capacity, and RAM size aren't keeping up with the amount of data generated. At the same time, the value of the information locked up in these data stores has never been higher. It's extremely difficult to maintain the processor speed to keep up with the enormous amounts of data of incoming data. With data mining, you can utilize the limited disk space and absorb the larger amount of data and incoming data for analysis. You might remember, was it just a couple of years ago when a terabyte was a Tera server, were these huge servers and this theoretical thing that people had in big data centers. Now I carry in my laptop a 500 gig. Actually, I have a couple of 500 gig external hard drives besides the couple of 100 gig hard drives I have internal. So I carry around a terabyte now with me in my laptop bag. So it's just crazy how this storage requirements have come. And I was working last night on one of those 500 gig hard drives, and it's full. Amazing. It's hard to where all this data is coming from. Within data analysis, there are two major forms of data. The first is structured data. Structured data is that data that exists in fixed fields when it carries a defined data type. Dimensional data, a form of structured data, is composed of facts in dimensions. Customer demographics, patient information, product properties are all considered types of dimensional data. Another form of structured data is the transactional data. Transactional data can be viewed as Boolean metrics. Transactions or objects are populated while recorded amount of transactions are computed in the corresponding column. Each examples of transactional data include products and amounts purchased, television shows viewed, amount of flights taken off, cost, etc. The other type of data is unstructured data. With unstructured data, there isn't a defined data type. While data mining is usually concerned with the detection of patterns in the numerical data, other information is stored in the form of text. This is considered textual data. Typical examples of textual data are considered customer feedback, phone transcripts, physician's notes, and my favorite, resumes. You can go through and mine for particular words or phrases of words inside of a resume or a pool of resumes and be able to pull that information out. There are various types of data analysis. Query report analysis, or QRA, is a form of analysis that will show what happened in the past. This type of analysis is generally a product of simple reports. Key performance indicators, or OLAP cubes. Analysis can also be conducted in real time. With real-time analysis, you're asking what is currently happening. Triggers or events are common practices used when attempting to gather real-time information, where they set off alerts during certain occurrences of forms of data or data changes. Both of these previous forms of data analysis, however, are limited in function. They only offer results from the past or the present. With data mining, however, you can ask what will happen in the future. Also, this type of analysis can show how and why something is happening based on certain behaviors. Data mining can offer the underlying reasons for instances and generate a better understanding of the future. In the next agenda item, you'll learn about what data mining does and the data mining process. The current process model for data mining, or CRISP-DM, provides an overview of life cycle data mining project. The initial phase of this process is an understanding of the business, when you focus on understanding the project objectives and requirements, as well as defining the scope of the problem. The data understanding phase begins with data collection. Next, the phase identifies the data problems and determines if the proper data is being used. Data understanding also defines the metrics by which the model will be evaluated in the final objective of the data mining project. The data preparation phase covers the collection of data from the other sources and additional computation for the final data set. Tasks include table, record, attribute selection. It also includes transforming and cleaning up of any data if we've got to bring it in from other different sources. In the modeling phase, the various modeling techniques are selected and applied. Also, their parameters are determined for optimal values. This stage is the model building stage, so change is certainly possible. Reverting to data preparation stage is typically to ensure that the business is building the ideal model. So you may have to go back to the data preparation and revert and then continue on. The evaluation stage determines which model is best in addressing the problem. In order to estimate which model will achieve the best objective, a thorough evaluation of each model is necessary. This phase finishes with a decision on the ideal data model is reached. And finally, depending upon the objective, the deployment phase can be as easy as generating a report or as complex as repeating the data mining process. With deployment, you determine whether the ultimate results will be suffice, or you need to run another run at a look at a different model. First, understanding what data mining is, we really need to start off with what data mining isn't. What is not data mining? Organizations have utilized ad hoc query tools to extract useful information from their data. However, as data volumes continue to increase, finding valuable information becomes more and more difficult. Data mining technology was designed to sift through detailed historical data to identify hidden patterns that are not obvious to humans or to query tools. Ad hoc queries, unlike data mining, are utilized when the user proposes different questions to the database. These are not considered to be forms of data mining because they are user-induced manual processes. Event notifications are pushed out in created instances when a certain event occurs. They execute in the responses to a variety of Transact SQL data definition language statements and SQL trace events. Event notification can be used to log and review changes or activity occurring on the database. However, event notifications cannot analyze the information like data mining can. Multidimensional analysis does not produce predictive or estimated values with associated accuracy expectations, whereas data mining has this functionality. Also, data mining is more powerful than multidimensional analysis when new knowledge and hidden information can be extracted through the data mining. And finally, data mining is considered to be the more than statistics. Data mining can cover the entire realm of data analysis, including data cleaning, preparation. Also, data mining can create predictions in real time. All these forms require analysis to the existing data, to examine that data. Instead of using someone to develop the hypothesis and research to the data, it's more useful to determine the relationships, predict the future events, spot bad data, and allow the analysis of the data in a way that has never been possible before. This can be accomplished through using data mining. So now we've gone through what is not data mining. Now let's talk about what is data mining. Data mining has been defined as the non-trivial extraction of implicit, previous, unknown, and potentially useful information from the data. It also has been defined as the science of extracting useful information from large data sets or databases. By combining these two definitions, we can categorize data mining into three areas. First, it's the ability to analyze large data sets. Several databases containing large data sets that cannot be analyzed by humans. Large data sets happen to have some existing relationships within the data, which can be extracted then for future analysis from the use of the data mining. Also, data mining is non-trivial. The data retrieved is not an obvious piece of knowledge. Data mining provides results based on data patterns, whereas other techniques may make it much more difficult to determine the estimated outcome. One example of this non-trivial is within the AdventureWorks sample database. Okay, so AdventureWorks is a sample database that comes with all Microsoft products. It's a sample bicycle dealership or fictitious bicycle dealership in the Northwest. Within this database, we want to take a look at trying to figure out what people buy a bike. So when you discover that car ownership is the most likely significant indicator of someone's likelihood to buy a bicycle, car owners that own 2 or 3 or more cars are most likely to buy a bicycle. So we'll use that as our example as we go through our demonstrations today. Finally, data mining is a useful tool. You can retrieve results that can aid you in achieving your ultimate goal, whether it's to boost your sales or improve your product inventory. The AdventureWorks sample database offers another good example of data mining as a useful tool. Earlier we were able to correlate a car and bike ownership. Now we'll be able to target sales and marketing material as car owners will try to boost sales while increasing the effectiveness of our marketing campaigns. So enough of the slides here. Let's take a look at our first demonstration. So I switch over to my test environment here. You may want to use Control-H or F5. It's a toggle, which will allow you to take you to full screen just so you can see the screen that I'm going here. I'm running a laptop to do these demonstrations today that's running Vista as my host operating system. As you can see from the very top of the screen, I'm running Virtual PC 2007. In my virtual PC environment, I've created 2 servers, so I'm running 2 different machines. One is a domain controller, so we can do some Active Directory type of things, and the other is this SQL Server box that I'm running here. So the name of the machine I'm going to run is SEA SQL 01, which is a Server 2003 box that I've got, that I've installed SQL Server on. So the first thing I'm going to do is I clicked on that little icon on the desktop there to open up SQL Server Business Intelligence Development Studio. It's hosted inside Microsoft Visual Studio. This is an application we'll be using for our data preparation process. So the first thing we've got to do before we can do any data mining is we've got to prepare the data so we can do mining. In our scenario here, we have a set of customers that we want to target with a new promotion. We want to find out the most profitable way of doing that. We want to maximize the revenue and minimize the amount of resources in order to obtain the additional revenue. First we need to do is create a new project. In Visual Studio you have various project types to choose from here. So if I click on File, New Project, it'll show me all the different types of projects that we can have. And prepare the data for data analysis, we'll need to create an integration services project. Let's call this one data preparation. So if I go to integration services project, and we're going to name this data preparation. And the solution name I'm going to call target, what do we want to call it? Target profitable customers. There we go. And click OK, and that's going to launch off my first project that we're going to build here. You'll see we'll build several different projects. We'll actually add on to this different project throughout our process. So once this loads up here, and it is a little bit slow the first time it comes up, but once you get into it, it moves along just fine. With this first integration services project, we'll do some data massaging. In this case, we want to build two data sets. We're going to look at a data set we pull from historical data table and divide it into two data sets. We use most of the data to train our data mining models. We are going to withhold some of the data so we can evaluate these models later on. In order to do this, we need to create a data flow task. Okay, so now that my design surface has come up, I'm going to go over here to my toolbox on the left-hand side, and I want to create a, let's see, what do we want to do? A data flow task is the first thing we do. Grab one of those and design it, put it on the desktop, part of my design surface here. Data flow task builds a data pipeline from extracting data from the source and populating the destination with our data sets. Okay, so notice we're in the control flow tab right now. Notice my other tabs here, data flow, event handlers, and package explorer. So if I double click on this data flow task, notice it automatically just switched me over to the data flow tab and created a new design surface for me. So the first thing I need to do is connect this to something. So I'll click on my toolbox again, and I want to connect to a source. So I want an OLEDB source, grab that out there and drop it onto my design surface. We'll create a connection to our SQL server that I'm running, SEA SQL 01, which holds the AdventureWorks data warehouse, DW data warehouse that ships with SQL Server as a sample database. Okay? So to build this out, I want to double click on this icon. Now my voice may be slightly ahead or behind what you're seeing here, so I'm going to try to make sure I tell you the exact click steps that I'm doing here. So now this brings up the configuration editor for a new one. So let me bring this box up again here, and I want to click on a new connection and click on, let's do new here. And the name of my server is going to be SEA-SQL-01. And I should be able to do a drop-down box here to make sure I pick which database I want to go with. AdventureWorks DW for data warehouse. And click OK there. That looks good, so go ahead and click OK there. And now I specify the table or view that I want to work with. We're going to pull a table called Target Mail SQL 11. This is inside the AdventureWorks DW database. I think it's all the way at the bottom here. Let me scroll down. There it is, next to last one in my list. So Target Mail SQL 11 is the name of the table we want to work with. When I've done this webcast before, people have emailed me after the webcast saying, hey, I couldn't find the Target Mail SQL 11 table. In the standard AdventureWorks database, it's not there. You've got to go to the AdventureWorks DW data warehouse one, and then you'll be able to find that one. So we go ahead and click OK there. All right, so now I've got a data source. So that's where we're going to pull our data source from. So what do we want to do with the data? So I'm going to transform the data. So I'm going to pick a data flow transformation. And the one I'm going to use, I've got to scroll down here a little bit, is percentage sampling. So I'm going to drag my percentage sampling out onto the desktop, onto my design surface. And so if I click back up to my OLEDB source, notice you get two errors here. I've got a red one if The output is not available, and I got a green one to make a good connection. So I'm going to click on, well, right over that green arrow, drag it down, and drop it onto my percentage sampling. Notice it creates a green arrow connection between the two. The percentage sampling transformation takes the specified percentage of your data and correlates it to an output. The remaining data is then submitted to another output. For our project, we want to use our standard 10% here. So double-click on that, and notice by default we get 10%. I could change this to whatever I want. And I've got both an output for sampling output and sampling unselected output that the information will be. Now I could, if I wanted to see the randomize for this, I could also see the randomizing counter as well. All right, so far in the design surface, I've created a source of data where we're going to go pull our data from in this percentage sampling function. Now we need to say, okay, once you sample this 10%, where does the data go? So I need a couple of destinations. So again, I go back to my toolbox on the left-hand side here, and we're going to pick 2 OLEDB destinations. And when I say 2, watch the process. I went and built one on the desktop and 2. So I now have 2 destinations that we're going to have output information go to. So I go back up to my percentage sampling here. Again, grab the green arrow here, drag it over to my first destination, and it's going to bring in an input-output selection. All right, and under the output list, I need to do a drop down here, and I want to do the selected output. So I'm going to take my selected output and drop it to this left one here. There we go. So that green arrow gets connected like we need it to. And then now I need to rechange the name of that. So let's go ahead and click on this first destination here, and notice if I just click right on the description there, it allows me to edit it. We're going to call this test data. Something I've learned over time is to not put any spaces in there, because notice we'll reference that name here in a few minutes. So test data is our first output. So I'm going to go now back up to my percentage sampling. Notice I get a secondary green arrow here, drag it over here to my second OLEDB destination. Notice it's going in my sampling unselected output. And I want to change the name of that one. Again, highlight that, and we'll call this one our training data. There we go. And so let's go over to test data. We're going to go through and edit some things here, and I need to tell it the table name to work with. And so I'm going to work with AdventureWorks DW build version. That's good. And click on New, which will go out there. And notice this is going to create a table. So here's a very simple create table name. So it's going to go out there and build a new table for me based upon this output. If you want to see how the fields are mapping, if I want to modify any fields, in this case, customer key is going to customer key. If I wanted to change the name of those fields, I could do that at this point. If I wanted to map a specific field into some other field, again, I could change all the mappings here if I wanted to do that. So let me go ahead and full screen that so we can kind of see our OK button. There it is. Click OK. That test data is done good. And I need to do the same for my training data. So again, I double click on that, click on New, Create Table, double check my mappings. Everything looks good. And we're good to go. All right, so that concludes our first demo. So what we've built here is an input source. We're going to do a 10% percentage sampling and creating 2 different output tables based upon this system. So let's go back to the slides here for a couple of minutes. Again, in that demonstration, we took a look at how to prepare data and sampling of that data for our first data mining exercise. So next we're going to take a look at the stages of data mining. There are 3 main stages of data mining. The first exploration is the exploration of data. This stage generally begins with data preparation. Preparation involves cleaning, transforming the data, which can be done with SQL Server integration services. The data is then exported, and it is determined which variables should be used for this project. After you determine how the variables to use, there we go, get my slides to advance to the next one, you'll find patterns in your data. This may seem like a basic operation, however, it involves a very elaborate process. This stage generally involves the evaluation of the different models. where you'll apply several different models to the same data set to find the best solution. An example of finding patterns would be discovering that the native Bayes mining model produces more relevant results than the neutral set or the decision tree models. So those are three: neutral net, decision tree, and native Bayes are three sample data mining models. Once the patterns are discovered and the ideal model is built, you can then perform the predictions. The final stages uses the model selection and applies it to the new data. With the new data, you can then generate predictions or estimates of the expected outcome. Examples of performing predictions would be the likelihood of buying a bike or ordering products over the internet or meeting organizational sales needs. So enough of the slides there. Let's get back to our demonstration. Again, remember F5 will give you a toggle so you can go back and see what we're demonstrating here. So let me bring my sharing screen back up. Again, I'm using the same demonstration. So we'll pick right up where we left off. Okay, so let me scroll up a little bit here, and we'll take that mining that we did before. We have our data flow package that will send data from one source into our two different data sets. Let's execute the package here and see the results. So I'm going to click on Start Debugging. Once we execute the package, it will pump all the data in. Notice it will change yellow first, which means the data package is executing. It'll pump through the percentage sampling of the transforms. You'll see the data start filling into my destinations here. And once everything gets executed, it'll turn everything green. Okay. Once everything turns green, we know we've got a good execution here. So let me scroll down a little bit so you can kind of see what's going on here. There, all four of our boxes are green. We got 1,800 rows in our selected output and 16,000 rows in our unselected output. So now let's go back up to our menu here and go to debug, and we want to tell it to stop debugging. Okay? To ensure that our package executed properly, we need to go and take a look to make sure that those tables were built that we just did. Okay, so let's minimize Business Intelligence Studio. Let's open up SQL Management Studio for just a second. And to prove to you that that pump of data did actually work, we'll connect with SQL Server Manager and go to Databases, AdventureWorks Data Warehouse, Tables, and there you go. There's test data and training data. Okay, so you can see that those tables do exist, that everything has been created there for us. All right, so let's go back now to the Business Intelligence Studio and our Target Profitable Customers project. So I come back up here to the top, and I go File, New. Now watch this. I'm going to tell it to create a new project here, but watch these steps real carefully. We want to stick to the same solution, so we want to add to the same solution instead of creating our own project. But this time we want to create an analysis services project we'll use to conduct our data mining. Okay, so in the solutions list down here at the bottom, instead of creating a new solution, I'm going to add to the existing solution. And instead of an integration services project, I'm going to do an analysis services project here. And let's give it the name of data mining. Okay. So we'll go ahead and click OK there. And you'll notice on the right-hand side here, if I scroll a little bit to the right, we now have data preparation and our data mining. This project's created new items which we need to populate. First, we'll need to create a data source. The data source is what defines the connection to the back-end database. It's how we'll find our data. So we'll go to Data Sources here, right mouse click, New Data Source. And it brings up a wonderful data source wizard. We want to make sure we're using my server, not the domain controller. All right, that looks good. Click on Next. I don't want to specify a username, so I'm just going to use a system account. And we're going to modify this one here. We're going to call this the customer data source. If I can type, there we go. And click on Finish. And so we now have a customer data source. Next thing we need to create is a data source view. A data source view allows you to define the scope of your problem. For this view, we're going to take the data source we just created. So go to Data Source Views, right mouse click, New Data Source View. Excuse me. And again, we're going to launch the Data Source View wizard. And here we want to pick customer data source. So the one we just created is a default here, so click on Next. Now it brings up the data source view, allows you to scope it. You'll have the view of the logical at the top of the physical connection that you made. Okay, so now we're to the point of the available objects that we want. So let's scroll down to, there's my test data we just built, so I'll bring that over. And training data, we'll work with it. I'm not going to bring over the entire database, okay? I'm just going to bring over the objects that I want. Now, we need to know information about customers, so if we use the dim customer table, there we go, I'll be able to get statistical information or actual contact information from the customers. Okay, so I've created 3 fields here, or 3 tables, test data, training data, and dim customer, which we're going to bring into this data source view. And we're going to call this one customer data view. There we go. And then click on finish. We're now able to set up different data mining models and process them against our test data. We'll do this in the next demo. So we got all our information all set, ready to go. Let's go back to the slides here, just again for just a brief session. So again, in that demonstration, we created our first project, which allowed us to be able to set up all the information that we need to go into our data mining. Let's return back to our agenda of what we're trying to get. Next, we're going to cover utilization of data mining. Data mining task. The first task is classification. Classification predicts one or more discrete variables based upon the other attributes in the data set. Examples include customer response, fraudulent transactions, and customized orders. You know, I had one the other day where my credit card, I was in, where was I? I was in Boston, and I normally don't use my credit card in Boston. And sure enough, it set off some trigger at my credit card company because I live in Texas, and they're like, what is your credit card doing in Boston? Well, I happen to be up there for work, and I normally don't use my personal credit card on business, and they called my cell phone up and said, do you know your credit card was used in Boston? I'm like, sure enough, that was me. So it's really nice to see when that kind of stuff works. Next is estimation. When you deal with continuous range of output, there isn't a specific order with estimation. What you could do is predict revenue or product longevity. Next is segmentation. This divides the data into groups or clusters of items that have similar properties. Segmentation will differentiate customers to you. Association finds the correlations between the different attributes in a data set. Association generally assists with placing combinations of products together. That's the old Amazon. Customers that bought this book usually bought X, Y, and Z, and allows you to promote other things. Forecasting attempts to project numbers into the future, such as revenue and inventory levels. Text analysis transforms unstructured data into structured data. Now, it also analyzes terms using other algorithms. Some examples of text analysis include feedback, call center data, and of course my favorite, the resume search. Advanced data exploration provides a descriptive analysis. It brings a deeper insight into the data with visualizations. Finally, advanced data exploration asks what differentiates one item from another. So let's get back to our demonstrations. Let's go back to my sample environment that we had. So we're going to click on that. Again, remember F5 will bring you up to full screen what I've got going on here. In our previous demonstrations, we prepared and sampled our data. Then we created an analysis services project. Now we're ready to do our actual data mining. Let's go into the data mining structures and create a new mining structure. A mining structure in SQL Server 2005 is a container that defines a problem space and attributes you're interested in and analyzing. It holds multiple mining models on top of the same problem space. The wizard creates the mining structure and the models within the structure. We can use relational data, OLAP data, or both. For this model, we're going to use relational data. Okay, so I'm going to go over here to the analysis services project that I already started in the last demonstration. We're going to click on mining structures, and I want to create a new mining structure. So I want to right mouse click on that mining structure and do New Mining Structure. This brings you to the data mining wizard. Okay, so we'll click on Next, and I want to go select Definition Model. I'm going to go pull data from existing relational database or data warehouse. Excuse me, if I wanted to use an existing cube, I could do that also. So now it says, what data mining technique do you want to use? So this goes through and gives us a description of the different ones. So here's clustering, decision trees, linear regression, logical regression, logistic regression, native Bayes, neutral network, sequencing clustering, and finally time series. So these are all different algorithms that help you do data mining. The first one we're going to use, and we'll use a couple of these, is decision trees. All right, so leave decision trees there and select Next. Next we need to define where our cases are coming from. Since we have a training data, we'll use that to train the model. Therefore, the cases are coming from the training data table. So here I want to make sure that I get everything, my custom data view. That looks good. And I want to go from training data. This will be my case checkbox. So notice I do that case, or I could do nested. So training data is where we're pulling the information from. The next thing we need to do is select our inputs. These inputs will dictate what we want to predict or analyze. We want to predict whether the customer is a bike buyer or not. All the other columns will be used as input. Since the bike buyer is predicted, we do not want to use it for input. All right, so let's walk through this. For bike buyer, so there's bike buyer, we want to do predicted, okay? And then we want to select input for all the other fields but bike buyer. Okay, so I want to make sure I clear that input box. Now we want to have a unique identifier for customers, which will be the customer key. Okay, so customer key we're going to create as our index or our key. Notice when I select that, that's no longer an input field. Next, we ask for additional information regarding the selection columns. Okay, so let's go ahead and click on Next here. Now notice something for a second here. The system has already found out the default values for the data types. It displays the content type, whether it's continuous value, a discrete value, a key, and so on. Also, it's taking the first stat based upon the data types as discovered from the data source view. However, some of the results may not be completely accurate. For instance, let's take a look at bike buyer. Since the underlying data type has several characters, the system believes it's continuous value. In actuality, there are only two values for this field, 1 or 0, yes or no, they're a bike buyer. So notice I can go through and click on Detect. So notice this Detect button here. So notice bike buyer today, right now, is continuous. If I click on Detect, notice it changes it to discrete. The results discovered there are two values of the bike buyer, so it changes it to this discrete. And so next, let's go ahead and click on Next. And we got to give it a name. So we're going to call this one Target Customers. Oops, if I can type this morning. And in the mining model field we're going to use, because we use decision trees here, I need to distinguish between the different mining models that I'm going to use. So I'm going to target customers, and I'll put the DTs. That stands for decision trees. Okay, and click on Finish. There we go. The wizard has taken us back to the mining structures editor. All the columns created with the mining structure are there, as well as the portions of the data source view that we used. We can now add additional columns to the mining structure if we want to. If we click on the Mining Models tab, okay, notice the different tabs that I've got here. So I've got Mining Models tab, and so there's the target customer's decision tree model that we just created. Now that we've created the initial model from the wizard, it becomes easier to add other models. Rather than going through the entire wizard again, you can use these settings from the previous model and create a new one by right-clicking the design surface and selecting a new mining model. Okay, so I'm going to go over here to the white space, right mouse click, I'm going to say New Mining Model. And the model name, I'm going to call this one Target Customers, and we'll do this one NB. What does NB stand for? We've got to take a different algorithm here, native veins. All right, so click OK there. It says, are you sure? Click on yes, and now notice I have both the decision trees and the native vein models built for me. We got that warning message because the algorithm does not support the content types within the mining structure. If we click yes, we'll continue to see the columns that apply. Ignore the columns that doesn't support by that model. What we have are design objects with the definition stored locally in XML files as part of the Visual Studio solution. But Analysis Services, which is where we'll be doing the actual data mining, is not aware of these objects. We'll need to deploy these definitions to the server before we can then process these objects. So let's go ahead and deploy. So how do I deploy this? Go over here, go to my data mining project, right mouse click, and deploy. Now this is going to take it a couple of seconds to execute. It'll go out there and take the definitions and create an XMLA format and send them over to the server. The server will then create a metadata objects, pull the data from the data source, push it through the mining structure. Once we have all the data put into the mining structure, we can then do data task and then pass the data through the multiple algorithms into each of the models of the data mining structure. Next, we'll learn how to evaluate the different models once they're built. Okay, so let's scroll down a little bit here and watch it build for just a second. If you'll look at the left-hand lower left, it says deployment started. So we'll give it just a minute here and watch this dialog box should change in the lower right-hand corner here in just a second. I'm going to take a quick sip of water here while we're waiting on it. Okay, I'm back. So let's see how there it is. It just popped up for us. So notice it shows our deployment process. It's going through the data mining. Server's local host, database is data mining. Notice the different steps it's going through. It's reading the cases, training the trees, building tree structures, training trees, reading cases, training trees again, going through the different models. And finally, yay, we've got the green checkbox here, deployment completed successful. So in that demonstration, we took a look at how to create and deploy objects. Let's see what's next. What are the capabilities of data mining? With SQL Server 2005, Microsoft has made data mining available to developers, database administrators, DBAs, for setting up and running data models. Any analyst, decision maker, or other user can use the output from the model with no special knowledge required. Data mining is made accessible and easy to use through an integrated user interface, cross-product integration, and familiar standard application programming interfaces or APIs. These standard APIs can be used for your own data mining applications deployed into production. Business integration offers an integrated user interface and cross-product integration inside SQL Server. There's also a full state of algorithms, which we'll examine later, to automatically extract information from your data. Finally, business integration also provides a complete framework that enables third-party data mining providers to integrate data mining objects into analysis services. These objects include algorithms, viewers, and web control libraries. Business Intelligence Development Studio is the first integrated development environment designed for the Business Intelligence Studio system developer. Built on top of Visual Studio 2005, the Business Intelligence Development Studio delivers a rich, integrated professional development platform for the BI system developers. As seen in our demonstration so far, this interface can create and explore data based upon your organizational needs. Also, you can create different models within the interface based upon your own personal preferences. Data mining provides projects that are inside of Visual Studio can create solutions with related projects. Finally, source control integration enables you to collaborate in creating a complete business integration solution. SQL Server Management Studio, also used in this demonstration, integrates management of all SQL Server 2005 components through this Management Studio, the BI platform components gain enhanced scalability, reliability, availability, and programmability. These enhancements provide significant benefits to the BI practitioner. This interface is a single place to do everything. You can manage it all in one location. Business intelligence interrogation offers strong and deep integration processes across the SQL Server. The new data flow environment offers dozens of transformations that help prepare data and join data mining. These transformations perform such tasks as sampling, lookup, as you saw we were doing the sampling in our case here, split, merge joins, adding derived columns, sorting, as well as extracting and loading data. Next, process mining models form unified dimension models using learned content, slicing cubes based upon data-specific parameters. These improvements in Analysis Services 2005 OLAP functionality enable new kinds of analytical applications either by adding functionality or by making it easier for you to build complex functions. It also increases the enterprise readiness for applications. Finally, business intelligence embeds data mining results directly into reporting services, as we'll see in a future demo here. In SQL Server 2005, the Reporting Services Report Delivery and Management Framework enables easy distribution of complex analysis information all over to different kinds of audiences. So now, next step is to evaluate our model. So let's go back into our demonstration environment here. Earlier we created a decision tree of native Bayes model to analyze our data. The next thing we want to do is to look at the model by clicking into the Mining Viewer tab. Okay, so let me scroll back up here and to the left a little bit. Mining Model Viewer. Okay, so I click on that tab. And let's start off with our native Bayes one. The first view we'll use is the dependency network. This predictability column is in the middle with all the other columns surrounding it. Arrows point showing to how much influence each column has on the final output. If you drag this all links indicator down here at the bottom, all the way to the bottom, you'll see links being removed based upon their strengths. For this model, the strongest link is the number of cars owned for the value of the bike buyer. So this is basically, if I own more cars, the more likely I am to buy a bicycle. Isn't that kind of crazy? I mean, I own 4 cars with my teenagers and everything, so they say I'm very likely to buy a bicycle. Well, then notice the next most influential thing is the total number of children they have, then how far they commute, education, number of children at home, and finally the least and most likely indicator is their marital status. Another interesting view is the attribute discrimination view. You can differentiate between the customers where the bike buyer value equals 1, they bought a bike, and customers where the bike buyer value equals 0, they didn't buy a bike. From here you can see what factors differentiate one type of customer from another. For example, you can see the differentiation from a car buyer, total children, work commuter, and so on. So to see this, what I want to go up here and do is the attribute discrimination, and I want to change value number 1 to a 1, so on or off, yes, they bought it, and value number 2 to a 0, and notice how it changes the data. So the most important factor is the number of cars they owned. And notice the number of children issues. And I've got a legend here, so I can see all that information. Now let's switch over to the different model. Let's look at the decision tree model. And the first thing I want to do here is zoom out because we can see everything. Scroll down just a little bit there. There we go. So you can see all the different models. Before we analyze, we want to color the nodes based upon whether all bike buyers are located. Let's change the color of the blue where the value of the bike buyer is now 1. And so let's change our background list to a 1. There we go. Notice only one of them changed to a dark blue. You can also click the nodes to get more details. So there's number of cars owned equals 0, total cases, what was that, 2,000? Oh, let me just double click into it. Notice on the lower right-hand corner here, I've got my mining legend. Let me resize that a little bit since we don't need all that space. So you can see as I click on different fields here, you can see there's my mining legend, and we can see what's actually going on. We have two models that have explored and attempted to understand the mining algorithm results. Now we can compare these two different models for the best result. Let's take a look at our mining accuracy charts. To do this, we go into these mining accuracy charts to get the results. From here you can select some input data to evaluate the models against. So I want to select the case table, and of course we want to use our test data. We'll use test data that we created in the initial data preparation. With this data, we withheld 10% of the data and placed it into this test data table. We'll now use this data for analysis. We're going to evaluate the two different models based upon how well they predicted a bike buyer to be a 1. Okay. And so let's see, what do we want to do next here? We want to select case table. And we've got that. So now we need to pull down our information. So for our source, let's see if I got my right table here. Let me make sure I picked the right field here. Yeah, so I want to add the source here. Excuse me, bear with me just a second. I think I'm trying to do the report menu and I'm backed up a step here. So let's making sure that I was in the mine models. Yep, that's the different viewers. Let's take a look at our accuracy. And let's see if I'm getting a lift chart yet. There we go. Okay, so notice the different lines that we've got here. The blue line is the random model. This means that when you look at 50% of the customers, you get 50% of your targeted customers. The red line that we've got is our lift chart. This is the ideal model line. It shows the results of the bike buyers. 51% of your population, you receive all your bike buyers. For the best results, you want to build your model that's higher than the random model and close to ideal as possible. And then finally, green is our lift chart. Okay, so notice I can change some of the chart type information here. I can go and modify all this information and change it to different settings so it'll show me which of the different models would be the best one. It does appear that the decision tree model does significantly better than the native Bayes model. All right, so in that one, we take a look at evaluating our two different models, decision tree and native Bayes, and deciding which one would be better for our solution. There are a number of algorithms available in SQL Server 2005. The decision tree algorithm calculates the odds of the outcome based upon the values in the training set. For example, a person in an age group of 20 to 30 that makes over $60,000 a year and owns a home is more likely to need lawn service than someone in an age group of 15 to 19 who doesn't own a home. Based upon the age, income, and home ownership, the decision tree algorithm can calculate the odds the person needs a lawn service based upon historical values. The association rules algorithm helps identify relationships between the various elements. For example, it is used for cross-selling solutions because it notes relationships between items and can be found to predict what else someone else is going to be buying a product will be also interested in purchasing. The association rules algorithm can handle incredibly large catalogs and have been tested in the catalogs over 500,000 items in size. Native Bayes algorithm uses, nope, sorry, was not forwarding my slides there. Let's just catch those up here. It's used to clearly show the difference in the particular values for various data elements. For example, the household income variables differs for each customer in the database and can be used as a predictor in future purchasing. This model excels at showing the differences between the certain groups such as customers who churn and those who don't. The sequence clustering is used to group or cluster data based upon the sequence of previous events. For example, use of a web application can often follow a variety of paths through the site. This algorithm can group customers based upon their sequence of pages through the site to help analyze users and determine if the paths are the most profitable than others. This algorithm can be used, for example, to predict the next page a user may visit. Note that the predictability capability of the sequence clustering algorithm is something that many other data modeling vendors cannot deliver. The time series algorithm is used to analyze and forecast time-based data. Sales are the most common analyzed and predicted data value using time series algorithms. This algorithm looks for patterns across multiple data sets so that the businesses can determine how different elements affect the analyzed series. Neutral networks are the core of artificial intelligence. They seek to uncover relationships in data that other algorithms miss. While neutral net algorithms tend to be slower than other algorithms, it finds relationships that they may be non-intuitive. And finally, our last method, text mining, appears in SQL Server integration services analysis to unstructured text data. This allows companies to analyze unstructured data such as comment sections or in customer satisfaction surveys and drill down and find interesting information. Earlier in the presentation, we discussed different data mining tasks. Now we can correlate the data mining algorithms with each task. Classification uses decision trees, neutral nets, native bayes, and logical regression. Estimation can utilize decision trees, neutral nets, logical regression, and linear regression. Association uses association rules and decision trees. Oh, sorry, I left off segmentation, skipped over that one. Algorithms offered for segmentation include clustering, sequence clustering, and new feature. Sequence clustering can also be used to analyze web behavior such as click-through screen data. There we go. There's our association. We already did that one. Forecasting. With forecasting, you can use time series. With time series, you can use cross-analysis across multiple time series. One time series is then available to predict another series. Text analysis using algorithms within integration services, where text extraction transformation and term lookup transformations are also available. Once the two transformations are run through the unstructured data, you can then use any SQL Server 2005 algorithms to analyze the results of your unstructured data. And then finally, you can also use the algorithms to search through advanced data exploration. So let's go through into our last demonstration here. We'll take a look at deploying the model through reporting services and get out the information that we just created through all this mining process. Now that we've evaluated our models and have the proper model that offers the most profitable outcome, we can deploy it in the actual call center environment. In order to deploy the model, we'll need to create a new project. This time we'll use reporting services. So I'll go up to File, New, Project, and we'll create a reporting service project wizard. And the name of my project, notice I'm still continuing to add to the same solution there in the bottom. Customers to call report. And the report wizard is going to launch for us. Based on our scenario, we want to generate a report that will be submitted to the call center. This report will show the people who have a high probability of converting into potential customers. In the report wizard, we'll need to select our data source, although a report will be coming from analysis services. So I click on Next, and data source. We want to do analysis services. There we go. And we want to click on Edit to edit our connection string. And tell it our server, and then what database do we want to pull from? Data mining. Okay. And let's test that connection to make sure everything's working good there. So click OK. And next. Next, the report wizard displays our query builder. So I want to go through and open up this query builder here and select which model we want to work with. And under target customers, there are the two different models we built. We'll use decision trees for this case. This is our best results. Next, we'll select the table that contains our target customers. So we need to go ahead and select case table. In this case, we want to select our customers, which is automatically defaulted for us. And then now we need to build the columns that we want in our report. Okay, so let's go through and walk through this. Excuse me. The first name, let's do that. Drag it to source. Let's do last name, drag it to source. And of course, if this is going to be a call center, we've got to give them the folks' phone number. So we're going to take the phone number, drag it to the source. Okay, so there's my first name, last name, and phone number, the typical things that we would see in an output field, right? Now we need to do our prediction function. So walk through this carefully. We also need to offer some condition space within the data mining. Let's add a prediction function. This option will select the predict probability. In order to have the column heading on the report, we'll also name the alias of prob. Okay, so let's walk through how to do this. The first thing you want to do is go to this blank source, click on the drop-down box here, and we're going to do predict function. And in our field, notice the different things I could do here. We're going to do predict probability. And in our alias, we're going to call this one prob. I'll capitalize it so you can see it in the report headings here in just a minute. Okay, so now I want to go back up here and watch how we kind of do this. You go up to the bike buyer in our mining model, drag that field down here, and put it in the criteria argument. There we go. So notice what that added for me. And I need to give it some parameters here, so I'm going to add a parentheses before it. Go over to the right. So there's my bike buyer for my decision tree, comma, 1, close parentheses. There we go. That looks good. So I got all the syntax correctly there. This will add our parameter. We'll have our bike buyer and set it to the value of 1. This will predict the probability that the customer is likely to buy a bike. So now we're going to add another prediction function with a where clause based again on the prediction function. We only want to target the customers whose probability of buying bike is above a certain threshold. So let's put a condition based upon it. This function will need to be greater than the maximum revenue percentage for the mining legend, 0.4528. So this will only target customers whose percentage is greater than that pink. Okay, so we're going to go through and do the same thing here. Same here. Go. I don't need to put a label on this one. I'm going to clear my show so this doesn't actually come up. So to populate this criteria, I'm going to highlight this one. Instead of typing all that in again, copy and paste. Now I want to add that percentage here, so greater than 0.4528. Press enter. I think we're all good to go now. So I can go up here to this icon and click in design mode. Now we can look at the query that it just created. Okay, so notice what it just did here. Scroll down a little bit so you can see it. Does a select from, and this is doing a prediction join. It's a special type of clause that joins models with the input data, which is coming in from open query. It then displays the prediction results based upon the joins. Also, there's a where clause. Okay, so if I scroll down a little bit here, we'll be able to see that where clause, where predictability probability is greater than 0.4528. All right, so let's go ahead and prepare our query. That worked successful. Here's our syntax is correct, so we can now move on. Click OK there, and OK here. Next, we can define the appearance of the report. Let's keep the default settings, which is a tabular format. So we did all that just to build the query for this report. Tabular format. And let's go ahead and grab all of our columns here and put those into our detail. and click on Next. And let's use the default style. This isn't report services. If you're into reporting services, I do another webcast on that. Notice here where we're going to expose that. So it's going to put it on my localhost report server, so I'll be able to have access to it. And we need to give it a name. Customers to call. Dialing for dollars. And click on Finish. And let's preview it. We can preview this report to examine our results. The report takes the model we placed into deployment and displays the contact information of the people who have the highest probability of buying a bicycle. You can now hand off this report to the call center employees and go dialing for dollars. This report is a beneficial tool to the call center and can use to target the customers who will be most profitable to the company. Rather than targeting the original 5,000 customers, you can instead find the top 500 or 600 customers to maximize our revenue. Okay, so notice there's the problem column that we added to our report, and so we can give the probability that that customer is likely to buy a bicycle based upon our data mining techniques. All right, so in that demonstration, we took a look at defining the model, creating a decision report from that information. With SQL Server data mining, you're able to make decisions without coding. Data mining algorithms learn business rules directly from the data, freeing you from trying to discover and code them yourself. Also, models are customized for each client. Data mining algorithms learn the rules from the client's data, resulting in the logic that is automatically specialized from each individual client. Changes do not need to be made to the application when you're able to recompile and reload. Finally, the client automatically updates itself. After your client's business changes, factors that affect the client's businesses are also adjusted. Data mining allows your application logic to be automatically updated through a simple process step. Applications do not need to be rewritten, recompiled, or redeployed. The data mining features inside SQL Server 2005 make creation of intelligent applications easy, thankful to a powerful but simple API. This API has the ability to call predictive models from the client applications without having to understand the internals of each model and how they work. This allows developers to call an engine, choose the model that provides the best result based upon the data analyzed. Data is then returned to a tokenized, meaning that the numerical values are then returned into a series of attributes. This allows developers to work with simple data rather than some new data format. Accessing the data mining models results in as simple as using a SQL-like language called data mining expressions to SQL, or DMX. The syntax is designed to be approachable to those who already know SQL Server. Also, we offer a managed object models for managing data objects and queries. You're able to write server-side store procedures with Common Language Runtime, or CLR, based upon the technology. And finally, Microsoft Analysis Server 2005 provides a powerful set of algorithms that can be used to solve a wide range of business problems. However, specific problems often require data mining algorithms that are not included in a particular suite. This is why the server provides a plug-in framework for extending the set of algorithms if you want to add some others. Well, that brings us to our conclusion of our summary. Data mining allows organizations to achieve the necessary information to form predictions or to determine underlying reasons on the specific behavior. An implementation of data mining in an organization will assist in uncovering trends and tendencies based upon historical data, as well as performing predictions, groupings, and classifications of data. SQL Server 2005 data mining tools excel from traditional data mining. Data mining models can now group customers based upon certain criteria, but the analysis can then be immediately start slicing the data based upon the new consumer or customer groupings. This ability to feed the results into the data mining models right back into the analysis process means the organizations can now determine how best to analyze their data. Microsoft has introduced several new data mining features in SQL Server 2005 that allows organizations to answer necessary questions. We've created a platform that spans the entire data mining process within integration services, analysis services, as well as reporting services, as you saw in these demonstrations. With this platform, developers won't need to create complicated decision trees and application code to achieve our best results. Heather, I'll turn it back over to you, and I'll go out there and see if Brian has any questions that haven't been answered.
All right, thanks so much, John. And if you do have questions for John, you can go ahead and submit those now using the questions and answers pane in the lower right-hand corner of your interface. I'd also like to remind everyone that you can print a PDF of the slides by going up to the File menu in the upper navigation bar. Also, watch your inbox tomorrow for an email with information about viewing this webcast on demand. This email will also include a link to a downloadable PowerPoint of today's webcast. And when you fill out the webcast evaluation today, you do have a chance to win a Microsoft Zune digital media player. So that's a great incentive from Microsoft. And we'll go ahead and launch the survey right now. You should be seeing it showing up in your slide area momentarily. All you need to do to fill it out is click on the links that you see on the middle of the screen. We do appreciate any feedback that you leave for us. We read all your comments, so it does help us to improve our future webcasts. So please do take a moment to fill that out. And John, do you have any questions?
Nope, looks like Brian's done a great job keeping up with them behind the scenes. Again, if you think of something after the fact and want to email me, don't hesitate at jweston@microsoft.com. We'd love to try to help you out with your data mining questions.
All right. Thank you so much, John. And with that, I will go ahead and end today's session. Thanks for joining us. You may now disconnect from the audio portion of today's conference.